Hey guys, this looks like a fun one. We're given a regular hexagon with a blue kite and a red kite. And it wants us to find the area of the yellow region. This is day 3 of the 2025 Aggvent Calendar. For the month of December, we're going to solve 31 Katrina Ag puzzles. How are you guys doing? I'm already a little bit behind schedule, but I will catch up. If you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, I want to try to write an equation that contains our question mark. We're given that this red region is a kite, so that means these sides will be congruent to each other. And we're also given that this blue region is a kite, so these sides will be congruent to each other. I'm pretty sure this is enough to assume symmetry everywhere, so this region will also be a question mark. And now we have an equation we can write. So it'll be these two question marks plus 9 plus 1, which is 10, equals the area of the entire regular hexagon. And now from here we can get the question mark all by itself. Let's subtract 10 from both sides of the equation. On the left-hand side we'll have 2 question mark, and on the right-hand side we'll have a minus 10. And then from here we can divide both sides by 2, and that'll give us question mark is equal to a divided by 2 minus 5. This is what we're trying to find. Let's put a box around it. And now what are we going to do next? I think we can prove that these two kites are similar. That'll be true if we can prove all the angles are congruent to each other. This angle and this angle are both interior angles of a regular hexagon. They're both going to be equal to 120 degrees. And then these two angles are vertical angles. They will also be congruent. And then in a kite, these two angles are always congruent to each other. So we can call these both theta sub 1 degrees. And then these two would be theta sub 2 degrees. Kites are quadrilaterals. They all have a total of 360 degrees. Since these angles match, all 4 of these thetas would be the same value, so let's just call them all theta. And now since our two kites have 4 corresponding congruent angles, we know they are similar. That means there's some scale factor A over B between the two kites. So the ratio of this side over this side would be A over B, or the ratio of this diagonal over this diagonal would also be A over B. And the area ratio is always the scale factor squared. So we can think of that as A squared over B squared. So now back to our kites, the area ratio is this area of 1 divided by this area of 9. And then 1 over 9 is the same thing as 1 squared over 3 squared. So that means the scale factor A over B can be 1 over 3. So if we call this side of the kite S, this side of this kite would be S over 3. And then if we clean things up a little bit, we can also draw this diagonal. If the green is X, then the purple would be 3 times that, or 3X. Pretty cool, huh? And I'm not certain what else we can do with the scale factors, so let's move on. Next, there's a really cool fact about regular hexagons. If we bring in all of these diagonals, this is made up of 6 equilateral triangles. So if this side of this equilateral triangle is equal to S, all of these sides will be equal to S. Let's mark this intersection point and clean things up a little bit so we can focus on this diagonal. In terms of S, this diagonal is equal to S plus S. And then in terms of X, the diagonal is equal to 3X plus X. We can simplify both sides of this to give us 2S is equal to 4X. And then we can divide both sides by 2 to give us S is equal to 2X. So we can change this S into 2X, this S into 2X, and this S into 2X. And now let's clean things up a little bit. We don't need this S. This X is redundant. And for now, since we have an X and a 2X, this 3X is also redundant. We can get rid of the S over 3, and we can also get rid of all this. And now let's bring back all of our equilateral triangles, and let's focus on this one right here. Since this side is equal to 2X, all the sides will be equal to 2X. And now we can write a formula for the area. The area of an equilateral triangle is root 3 over 4 side length squared. And in this case, the area would be equal to root 3 over 4 times the quantity 2x squared. To simplify this, the 2 and the x can each get their own squared. 2 squared is equal to 4, and this 4 and this 4 can cancel each other out. So we're left with x squared times the square root of 3. And we now have the area of this equilateral triangle in terms of x. And now that we have the area of one equilateral triangle, we can find the area of the entire hexagon. It's equal to 6 of these. 6x squared square root of 3. This looks important. Let's move it down here and put a box around it. And now we got to solve for x. Let's clean things up a little bit and bring us back to here. Let's now focus on this triangle. We have the purple side is equal to 3x and this side is equal to 2x. We also know that this diagonal bisects this interior angle of the regular hexagon. Since the whole thing is 120 degrees, this this would be 60 degrees. And now we can find the area of this triangle using these notes right here. For any triangle, if you know one side, another side, and the angle in between them, you can find the area by doing 1/2 times this side times this side times the sine of the angle in between them. So let's do that for this triangle. The area would be equal to 1/2 times 2x times 3x times the sine of 60. And now we can simplify this. For the left-hand side, we do know the area of this triangle. This diagonal cuts the kite in half, and the area of the entire kite is 9. So the area of this triangle is 9/2. And then on the right-hand side, 1/2 times 2 times 3 is equal to 3. X times x is equal to x squared, and the sine of 60 degrees is √3/2. And now we have an equation in terms of x. Let's solve for x. Let's rearrange things a little bit and multiply both sides by the reciprocal of this. On the left-hand side, the 2 on top and the 2 on bottom will cancel each other out. And then the 9 divided by 3 can simplify to 3. And then we have 3 over √3, which we can still simplify further. We can change this 3 into a √3 times √3, and then this √3 and this √3 will cancel each other out. So on the left-hand side, we're left with square root of 3. And then on the right-hand side, all of this will cancel out. We'll be left with x squared. And then from here, we can square root both sides, and that'll give us the 4th root of 3 is equal to x. And now we have a value for x. We're almost done. Let's break this out of the box, and in the place of this x, let's plug in 4th root of 3. The 4th root of 3 squared is equal to the square root of 3, and then square root of 3 times square root of 3 is equal to 3, and 6 times 3 is equal to 18. So the area of the entire hexagon is equal to 18. And then from here, let's break this out of the box. In the place of the hexagon, we can plug in 18. 18 divided by 2 is equal to 9. And 9 minus 5 is 4. And that is the answer to our question. In this given hexagon, the area of this region is equal to 4. Let's put a box around it. How exciting. This problem was day 3 of the 2025 Aggvent Calendar, and this is the problem for day 4. We're given that the 2 red squares are the same size and the 2 blue squares are the same size. We're also given that the base of the larger figure is equal to 6. And it's asking us for the total shaded area. This looks like it'll be a fun one. How exciting.